bird's picture here. We're going to label this quadratics. And we are going to draw our y-axis through our bird and through its little slingshot here. So go ahead and draw your y-axis through here. So we have our y-axis right here, and then our x-axis is going to be right at the grass line. So label that. So I've got my x-axis, I've got my y-axis. Now let's give ourselves some green grass. So got some green grass here. Now, the green grass is all above the x-axis, right? Now, under just where the grass hits the x-axis, what do we find? Is the grass just laying on top of there? No, it's growing. So what is under the surface? Just under that top surface where it's green. What's underneath? Roots. So let's draw some roots. And that is handy to remember because any place that your graph intersects that axis is a root. Okay? So we're going to draw our graph, and let's give it a color so we can actually see it here. Let's let our, well, we're going to color our little bird red here. Got a little red bird. And when you draw your graph, the pathway of that bird, I want it to end before you hit the pigs. So I'm going to draw that. Now this is a parabola. So that is the path of my bird. And we're going to label that, it is a parabola, spelled parabola. Make it a little darker here so you can see it. Okay, now where the red bird is sitting, what would that be considered? That would be my y-intercept, or C. And then over here, we're going to write a couple little notes here. Actually, we can write it underneath. The standard form is y equals ax squared plus bx plus c. Remember we saw that c, actually you could make that c, if you made your bird red and your y-intercept red, we could make that c red. Because when it's a y-intercept, x is 0 and all these things go away. Okay? The other thing we want to write beside underneath that is vertex form. Now you guys have played with vertex form, and we're going to do that a little bit with our exponential. And the vertex form is y equals a times x minus h squared plus k. And your vertex is h comma k. Now, at the top of this parabola, does it have a max or a min? Does the parabola have a maximum or a minimum? A maximum. And where would that maximum be? At that top. So we're gonna let's use a different color because I need to make it dark enough that you can see. Oh well, we're gonna be stuck with I'm just gonna use 10, I guess. Oh, I do have purple. So this point is our maximum. And we have this line. Does anybody remember what this line is called? Anybody remember what that line is called? I actually just taught it in geometry or in the transformation. Huh? Line of symmetry. Sometimes you'll see it as line of symmetry. I've also seen it as axis of symmetry. Now the equation, well first of all, that line is a vertical line. So is it going to be an x equals or a y equals? X equals. So does anybody remember it? X equals what? How do we find that? It's got B's and A's in it. Negative B over 2A. That is for our axis of symmetry. Equation. Now this point is going to be, the maximum is going to occur when I plug that answer, what I get here, in. So it's f of negative b over 2a. So we're going to put plug in axis of symmetry. What spits out is going to be your max or your min, because that coordinate is whatever this is, comma, what happens when you plug it back in. So that's our maximum. Alright, now the last thing that we need to label in here are our roots. Now there are three different, actually maybe more than three, that we can use for this. So these guys are called roots. They're also called, or actually this point right here is considered a root, an x-intercept, a solution, or a zero. That point right there and that point right there. Roots are found where the graph crosses the x-axis. So, you draw a circle around where that graph crosses. That is called a root, an x-intercept, a solution, or a zero. Those four terms refer to that point where your graph crosses. Okay? So, that's graphing. So everything, this is a good reference sheet. You've got little sticky notes. You might put a sticky note on this because this will be a nice summary of kind of what we're doing.